Hello guys, do you know the water which we are using every day, without which there is no survival? That water, how it is studied, or what are the different points which can be studied under the water? Yes, this is Dr. Jyoti Shegokar, and today we are going to study the topic of water, that is hardness of water, in somewhat detail, which is one of the most basic topic of the engineering chemistry, which is there in the very first unit. Guys, water, we know that water, it is there in the different states in the environment. Whenever everyone knows that how the water cycle is there, when water is there in the clouds, it is there as a solid water. When it rains and falls on the ground and flows and gets stagnant, or sometime it remain flows, so that water, it is a liquid water. And when there is a evaporation is continuing during the sunny days or summer, that water is a water vapor. In this way, that water, it is found in the different states in the environment, and during that, when it is studied, it is called as a water cycle. And that during that water cycle, in between that, the human beings or animals or plants are there which are requiring that water, and it is taken by it. So that water, when which is required, for example, for the human being, when that water is required, is it directly, or can it be directly drunk? No, there is a requirement of processing. Why there is a requirement of processing? It is because that water is not totally clean or pure. Generally, the rainwater, which is a, we can say that it is a very pure form of the water, natural water, that can be drunk. But during raining, when the number of gases are interacted with the water, it gets dissolved in that water, as water is an universal solvent, and it becomes mixed with that different salts. And when water, when once fall on the ground, it gets percolated under the ground. Some water gets absorbed by the earth. So during the percolation, when it flows through the under the ground, flows to the different type of layers, number of salts or minerals get dissolved in the water, and that water becomes hard. Yes, in this way, there are two different types of waters: that water which is under the ground, and water which is on the ground, that is the surface water and underground water. Now, the surface water which is there, or the rainwater which is there, it is a generally very pure form, but when it gets inside the earth surface, it becomes hard, and that water is a hard water. So can that hard water be directly used? When that water is used as a well water, as a bore water, as a spring water, it cannot be directly used because of presence of different salts present in it. Now, whenever that water just percolated under the ground, at that time, number of layers are there which are working there as a filter, and that water becomes very clean. When we see bore water at our home, we can see easily. So that water is a very clean, but is it very pure? No, because of presence of some invisible salts in it. So on that basis, there are different type of impurities of water, which we have seen in one of the video in our channel, that is impurities present in the water. There are 4 different types of impurities. If you want, you can get the link in the description box of that video. So guys, there are 4 different types of impurities: suspended impurities, colloidal impurities, biological impurities, and dissolved impurities. So dissolved impurities are one of the very important and harmful impurities, because they cannot be seen by naked eye. Water can be seen very, very pure and very, very clean, but it is having that type of impurities, and that's why there is a need of number of filters or number of softening processes required for the water to make it more clean. Okay. Now, what is that hardness? As I said you, when water gets percolated under the ground, or it may be remain on the earth surface, and number of salts from the earth surface can dissolve in the water becomes hard because of including or because of dissolving that different salts in the water. And when that different salts are dissolved, it is called as a hard water. That is the type of dissolved impurity, hard water. Now, the water which is having these salts present in it, it is a hard water. And in the same way, when that salts are absent from the water, it is a soft water. So in this way, water can be classified into 2 different types, that is soft water and hard water. Okay. Now, what is hardness? What is that actually property? Now, when at our home, generally we can carry out this experiment also. Just take a sample of water, bore water and tap water. Tap water, sometimes it may look a very dirty or muddy or having silt in it, but it is still the pure, we can say, or soft water, because it doesn't have the dissolved type of impurities. While those water which is from the bore, that water may look clean, but it is having that type of impurities. And when just take the two different samples of the water and mix some soap solution in it. So whenever there is a mixing of soap solution in it, soap solution means those soap which is at our home or detergent, make it solution with another water, a minimum amount of water, and mix it into that, both the solutions. Those solution in which there is a presence of lather or foam, by mixing properly or stirring, that is soft water. But while when that water, when in the sample in which the soap has been mixed and there is no any lather or any foam, instead of that we can see the white curd like precipitate which is very sticky, that is called as a hard water, that sample. So what can we study from this particular experiment? So here I wrote already the reaction. You can see this reaction to study the hardness of water. So here this is called as a sodium stearate. So the C17H35COOH is a steric acid, means 17, the acid in which there is a 17 membered carbon is present, it is called as a steric acid. In the same way palmic acid, in the same way some another type of acids which are having a higher fatty acids present in it, means having the more carbon number. Now when its salts is formed with a sodium or potassium, it is called as a soap. Okay, now that is produced by the saponification reaction. We know this thing. Now this soap, when once it is there, its name is a sodium stearate. Sodium stearate, because it is a salt of stearic acid, sodium salt of stearic acid. And this salt which is there, which is shown here, calcium chloride. Now those salts which are responsible, just I said that salts or minerals when they are mixed, that salts includes the calcium chloride. In this way number of salts of calcium, magnesium and others also there, but prominently calcium, magnesium salts are there, like calcium chloride, calcium sulfate, calcium bicarbonate, magnesium bicarbonate, calcium carbonate, magnesium carbonate. In the same way ferrous sulfate, aluminum chloride, ferric chloride, that type of salts, whenever they are present in the water, that water is a hard water. Now how they will react? So here there is a reaction with water, but instead of water, due to presence of these salts, it will react with that soap. So when it react with that soap, you can see here there are 2 moles of this stearic acid or sodium stearate are required. And whenever there is a reaction with calcium chloride, means with a water, but instead of water there is a presence of salt, so it is a hard water. So from the hard water, when this calcium chloride is treated with sodium stearate, there is a formation of calcium stearate. We know that calcium is having a di-positive charge on it whenever it is having the valency of di-positive, or we can say oxidation state of 2, and it is because when there is a 2 oxidation states, it will require 2 different negative charge ions, and in this way single calcium can consume 2 different stearate ions, and here there is a formation of distearate. So it is a calcium stearate is formed there with a removal of NaCl. So NaCl, it is again salt is produced, and with the salt calcium stearate, and this calcium stearate is white scum. It is a curd-like precipitate, just as I said, which is called as a scum, which is not useful anywhere. Whenever it is used on clothes, it will form the different type of rashes or a different type of cracks or grey colored patches will be formed there. So in this way, this scum, it is not useful ever. So that's why when the salts present in the water, instead of salts, if there is a soft water, what would have been possible? That when there is a presence of soft water, here there is a reaction with H2O, and with the H2O, here there is a formation of acid, that is stearic acid, and sodium hydroxide, which are there for the reaction continuously on the cloth wherever it is to be required, or it is to be removed for removal of stains. So in this way, here there is a consumption of the different type of ions. Okay, and that's why ions from the soap, and that's why it is called as a soap consuming capacity of water. So what is hardness, guys? Hardness is nothing but the soap consuming capacity of water. And also there is a prevention to the lathering of soap. We have seen just, so it is also defined as the prevention to the lathering of soap is nothing but hardness. So hardness, we know that it is nothing but presence of different salts present, but it is defined systematically or professionally as it is a soap consuming capacity of water or the prevention to the lathering of soap. So this is just a definition which we have proved here. So in this way there may be the question that how it is the soap consuming capacity of water. So during that this reaction is must and explanation is also. Okay, now moving further, that whenever the different salts present there, what type of hardnesses are there? So there are two main types of hardness we have seen, or there is given this hardness in our earlier videos, you can see. But just in a brief, that hardness are of two types: temporary hardness and permanent hardness. Temporary hardness is also called as a alkaline hardness or also called as a carbonate hardness, while temporary hardness is in the same way that non-alkaline hardness or non-carbonate hardness. Okay, now when we see temporary hardness, from that word itself indicates that it is temporary, it can be removed easily. Yes, so the hardness which is having calcium carbonate, calcium bicarbonate, in the same way magnesium carbonate and magnesium bicarbonate, means carbonates and bicarbonates of calcium and magnesium, whenever they are present in the water, that hardness which is there in the water is called as a temporary hardness. While the remaining one that I said, the sulfates, chlorides of any or any another type of some gases are there which gives the different type of smell or odor to the water, some different type of impurities, all will be included in the permanent hardness. But temporary hardness is only the carbonates and bicarbonates of not only calcium but magnesium. So only there are 4 salts responsible for the temporary hardness, and that is called as the carbonates and bicarbonates of the calcium and magnesium. That is called as a temporary hardness. Okay, and what will be then the permanent hardness? Permanent hardness is the hardness for which the other than carbonates and bicarbonates all the salts are responsible, and that is called as a permanent hardness. So that word which is there, so it cannot be easily removed. So that's why it is a permanent. The different type of non-carbonate type of salts are responsible. That's why it is a non-carbonate, and non-alkaline type of nature it is having. That's why it is a non-alkaline. So in this way there are 2 types of hardness: temporary hardness, and as it is said that temporary hardness, it can be easily removed. Now we are going to see that how it can be easily removed. Next topic. So here we have seen 2 types of hardnesses, that is temporary hardness and permanent hardness. Okay, now how the temporary hardness can be removed? Here I have written already 2 reactions, that is calcium bicarbonate and magnesium bicarbonate. Calcium bicarbonate is there, and this one is a magnesium bicarbonate. Now what will happen? As I said that carbonates and bicarbonates are responsible for the temporary hardness. Here we have seen the reaction, we have to study the reactions with calcium bicarbonate and magnesium bicarbonate. Why I didn't take the carbonates? It is because carbonate, whenever it is there, it is considered as a permanent hardness. Means whenever it is there in the cold water or in the normal water, at that time whether the carbonates are present, whenever there is a reaction or boiling process is there, it will be converted into carbonate. Means it will remain same as a carbonate, but it gets reappear. That means it is a permanent hardness. Reappear means formation of precipitate is there. While bicarbonates which are there, they are again converted into carbonates. Means whenever the product we will see, all precipitate is of carbonates. So that's why here only bicarbonates are considered. Carbonates will remain as such, but it will reappear only. Okay, I hope that you are getting it. Okay, now here bicarbonates, whenever it is there and it is undergoing with this particular type of heating process. So at a high temperature or for the continuous boiling of half an hour, just we have to take a sample of water and it is continuously boiled up to half an hour. There is a systematic process of boiling also, and after half an hour heating, it doesn't put with any type of lid, so that the different type of that water can be vaporized also and it can get minimized. So the volume of water get minimized. So just if we consider the volume of 250 or 250 ml of water is considered for the boiling process, there is a remaining of only 50 ml of water. So that 50 ml of water, after boiling for half an hour, just take it aside and then remove the or carry out its filtration, so that the salts which are reappeared, that will get removed. Now how that salts are reappeared, what will happen here, bicarbonates are getting converted into carbonates. For example, calcium bicarbonate which is there, it is converted into carbonate of calcium, and this carbonate of calcium is in the form of precipitate, that means in the solid state, and with the removal of this H2O, which will be there as a clean water, and also this carbon dioxide gas will be removed. So in this way, these bicarbonates are converted into carbonates, which are in the precipitate and can be removed easily by the process of filtration. And in this way, we can get a very clean and clear water. So we have proved here that temporary hardness is can easily removed by the process of boiling, while another salts which will be there or which are there cannot be easily removed. So in the same way here, when we see magnesium bicarbonate, this magnesium bicarbonate, here there is a formation of magnesium hydroxide, unlike this magnesium carbonate. This magnesium hydroxide which is there, and after formation of magnesium hydroxide, there is a removal of carbon dioxide, 2 molecules, but this reaction again gets further proceeded and formation of MgCO3. So magnesium carbonate will be formed at last with the removal of number of remaining carbon dioxide molecules. So this magnesium carbonate is again there as a precipitate. So that is called as a boiling process or removal of temporary hardness from the water. So in this way, temporary hardness can be easily removed. So there may be the question that how the temporary hardness can be easily removed. How can you say that it is easily removed? So this total is the answer of that same. Okay. Now moving further, next is a CaCO3 equivalent of the substance, or it is also called as a degree of hardness. Guys, degree of hardness means how to carry out the calculation of hardness of water. There are number of numericals given that carry out the calculation of or determine the temporary hardness, determine the permanent hardness, or this type of problems are there which will require degree of hardness. Now for this degree of hardness, there is a one particular salt which we have to consider is a calcium carbonate. So calcium carbonate is considered as a standard hardness causing salt. Now there are 2 reasons behind it. Number 1 is that it is having its molecular weight 100, will require its molecular weight. So for the sake of convenience of the students, for getting it more easy, there is a this particular salt is considered. And the second reason is that whenever this calcium carbonate is present, it comes in the precipitate form very fast. So that is again one of the reason, and generally it is found in the water as a hardness causing salt. So this with these particular reasons, that calcium carbonate is considered as a standard hardness causing salt. Whenever there is a calculation of hardness, there must be the use of this calcium carbonate. It is because that it is having its molecular weight 100, and it reappears in a very very fast in the solid state. Okay, now here how can we calculate it? Calcium carbonate equivalent of the substance. It is also called as the calcium carbonate equivalent of the substance. Okay, we will see it afterwards. Then is equal to weight of the substance. For example, we want to calculate this equivalent of the substance of the calcium sulfate. Okay, now here how can we calculate the degree of hardness for this particular calcium sulfate? So we have to write here weight of the substance, that will be given in the problem, that how much weight of calcium sulfate is present in your problem, in your water amount of water. For example, it is present in the x ml or x milligrams. Okay, now equivalent weight of calcium carbonate. So as we know that molecular weight of calcium carbonate, by adding the atomic weights of the different substances, that is calcium, carbon and oxygen in the 3 times, so it will be 100. And if you want equivalent weight, it must be divided by the valency of the central metal ion, which is +2, and if it is divided with +2, we will get here 50. So 50 is the equivalent weight of calcium carbonate, and divided by equivalent weight of the substance. Substance means those we want to calculate here. So here we have to calculate the equivalent weight of this calcium sulfate. So calcium atomic weight, sulfur, oxygen. So it is divided with the equivalent weight of that particular calcium sulfate. And in this way we can get easily the CaCO3 equivalent of the substance. It is called as the CaCO3 equivalent of the substance. So in this way we can calculate by putting the value of equivalent weight of each substance which is to be, of which calcium carbonate is to be required, that can be put here, and we can get the CaCO3 equivalent of each one. And whenever if there is a problem that calculate the hardness of this particular amount of water in which the different salts are present, so at first we have to calculate CaCO3 equivalent of each one. That means degree of hardness of each one, and then it is to be added, or some summation is done, and then we get the hardness of water in means total hardness of water. So in this way, here we have studied, guys, that hardness of water in terms of its types, then its definitions we have seen, then its degree of hardness, and how can we remove the temporary hardness, that also we have seen. So guys, if you are new for the channel, subscribe the channel, and like the video if you are benefited with the particular video, and also share to your friends who are requiring the same video. So guys, thank you for staying tuning with me. Thank you very much once again.